Welcome back. We're starting a new unit. This unit is all about something called arrays. We'll create some arrays, we'll play with them a little bit, learn about array traversal, and we'll recap everything that we learned in these slides. In many programs, you'll need to manipulate collections of related values. An array is an object, all right? So this is not going to be one of those 8 primitive data types. An array is in fact an object that stores a sequence of related values. The values are stored in an array are called elements. The individual values that are in the array itself, we call those elements. Here's our construction syntax, right? I put this here because it is the syntax. I find it to be misleading because the example is probably the best way to illustrate the concept. Here we're saying we're going to create an int array called numbers. That's really just variable declaration on the left-hand side. On the right-hand side is the actual object itself. Let's break apart this construction statement and talk about what's happening. In this construction statement, we'll construct a new array object that stores 4 integers. That's actually what's happening over here on the right-hand side. The variable numbers, which is on the left-hand side, is declared and then instructed to reference or point to that object. It is always going to be important to remember that a variable and the thing that it is storing or referencing are 2 separate entities, right? Variables can change over time. Numbers can be told to basically point to a different array. If this was just a single integer like x, it can change over time, right? Variables can change. The thing that's on the right-hand side is more of a literal. We saw this a lot with numbers. We saw it a lot with strings. It's going to be very similar with our arrays. So I want you to think of the integer array, numbers, as just a variable, a separate entity from the actual array itself. An array is essentially a list of values or elements that is limited to a specific type of value. This is going to be one object. This is going to be one list, effectively, that can store multiple integers. Visually, it looks something like this. I have the variable, numbers, and it is referencing or pointing to an integer array. Here we're illustrating that the maximum number of elements that an array can store is called its length. In our example, we have a length of 4. So in these brackets over here, whenever we're creating the actual array, we're saying that it can hold a maximum of 4. That is its length. There's a couple of notes here. Length must be a non-negative integer. By saying non-negative, right, and not positive, that means that 0 is a possibility. In practice, we won't ever really use 0, but you need to be prepared for it. You need to know that 0 is something you can do. That's the only time it gets used is in concepts that are well beyond this class and maybe even the next one, right? I don't ever really create arrays with a length of 0, but it is possible. Once constructed, an array's length cannot change. That's going to be super important, right? So this integer array here has a length of 4. Period. It cannot change. It cannot go up. It cannot go down, etc. While it is possible for an array to have a length of 0, the length must be specified upon construction. So I'm talking about these construction statements here, where I'm actually creating the new Boolean array. Now, it is okay to have a length of 0, as shown here. What you can't do is include nothing. Okay? So here we're also seeing that a Boolean array is possible, right? This is able to hold true and false values. Well, technically none because of the length of 0. It is also possible to have a char array, which, by the way, is basically a string. Basically, right? This is going to be a list of individual characters. That's kind of what a string is. When an array is constructed, all of the elements are initialized to the corresponding default values. We got to talk about what those are. It's a bunch of zeros, right? I've highlighted in red kind of the data types that I expect you to know for this course. And we kind of know char, but we're not going to ever make a char array. Here we see int, the default value is 0. Double is 0.0. False for Boolean. I like to think of this as the 0 of Boolean. It's like zeros the entire way down. Now this char, this is the Unicode position 0. I've shown you a Unicode table before. I'm not going to bring one up, but if you're super curious, you can bring up a Unicode table. Basically, every character that you can possibly produce is already mapped out into a table with a position. And so this is that first position, which I think is, it's not 0, the character, which I've traditionally said in the past. It is the 0 spot on the Unicode table, which is like a tab or an enter or something like that. I'm not positive. Okay. Numbers, this integer array that we're creating here, will be filled with zeros because it is an int array. If it were a double array, it would be filled with 0.0, and a Boolean array is filled with false values. So depending on the data type of your array, in our example here, it is an integer array, we're going to default to the default value for int, which is just 0, right? If it was a double array, it's going to be 0.0 if it's a double array, and if it's a Boolean array, it would be false. That's what this slide is saying. So right now, visually, it looks something like this. We have numbers, which is the variable, slightly different. This is a variable that is capable of storing or referencing, pointing to an integer array. This is the actual integer array itself. This is the actual object on the right-hand side. Okay, we see that it is an integer array with a length of 4 slots, and we haven't put anything in it yet. So it's just the default value, which is going to be zeros. So now that we have an array that exists, is filled with zeros, we need to talk about like editing it, accessing these elements. Each element in an array can be referenced via a non-negative integer index that is placed inside square brackets. Again, we see this non-negative thing. Our syntax is we're going to take the name of our array, brackets, and then the index, the position that we want to actually access. So for example, numbers at 2 will refer to the int that is stored in the third index of the array that numbers is referencing. Right? It's important to note that array indices begin at 0, not 1. Okay, this is actually going to be intuitive to you at this point after working with strings, but note here we see non-negative integer index. Again, that means that 0 is a possibility. Our indices for our array start at 0. That's a good thing, especially now that we've been working with strings, that this is cohesive, and that makes sense, right? If for strings it was index 0 and for arrays it was index 1 or vice versa, you would go absolutely insane switching back and forth between those objects. But this is cohesive, intuitive at this point. So our first index is 0, 1, 2, 3. So we see that with our length of 4, what our actual indices end up being. So with our square bracket notation, we can refer to the individual elements. In this case, we're talking about numbers. That's the array. So I will take my array, using the square bracket notation, I will access a very specific element in the array. So it's one of the items that are in our list. Okay. Here, right, we're talking about just accessing it. Here, we're actually going to talk about editing it. So I can take that position, that index, and I can change it to 7. Visually, that's going to look something like this. When we first create numbers, it's filled with zeros, but then I come along and say numbers at 2 is now a 7. Cool. Attempting to access an index that does not exist will generate an index out of bounds error, right? We talked about these. We first got introduced to these when we were looking at strings. But a negative index, that's going to be out of bounds. An index that is equal to the length or more will be out of bounds, right? This has a length of 4. If I try to access index 4, that doesn't exist. Okay, that'll give you an index out of bounds error. Specifically with the array, it'll say array index out of bounds error. And the only reason why I mention that is if you have arrays and strings in the same program, IntelliJ is going to give you the error, or whatever Java IDE you're working with is going to give you the error. It'll say array index out of bounds, indicating that your array went out of bounds. It may say string index out of bounds, indicating that your string went out of bounds. So that'll help you debug, recognizing that the index out of bounds error is slightly different. Just like with string, this is going to be a runtime error, meaning you won't experience it until you tell your program to execute. So a negative index is out of bounds, and an index that is greater than or equal to the length is out of bounds, right? So 4 is out of bounds, and 5, 6, and so on. So in order to avoid this, we need to know at various points how long is our array. Maybe we're doing a coding bat, wink, wink, and the array coming in is not one that we made. We have no idea how long it is. Well, we're going to need to use length. Okay. Here's one thing I'd like you to notice. There's no parentheses here. We've seen length. We've seen this idea of length before whenever we're working with strings, but it had parentheses. Okay. Length is not a method here, right? We've talked about methods a little bit. We're talking about calling methods. This ain't a method. This is a public final instance variable. Yuck. Okay, I hate this. I wish they would have picked one or the other, right? I wish this was cohesive between string and arrays. Either choose one or the other type of thing. You're just going to get used to it. When you're working with the array, it's length with no parentheses. When you're working with a string, it's length with the parentheses. I'm sorry. I don't know what to tell you. Using length, we can refer to the last element of the array dynamically, just like we did with strings, right? So I want to go into numbers at, right, this is what these brackets kind of mean, at a particular index. This index in question is numbers.length -1, and I'm going to change that to 23 in this example. Okay, well, the length of our array is 4, so -1 gives us a value of 3. This is the last element in the array. Right? If I backtrack and look at a visual, index 3 is our last index. In my example here, I'm changing it to 23. Additionally, attempting to assign an incompatible data type to an array will cause a syntax error. Right? Numbers is an integer array. It's capable of storing ints, but I'm trying to, in this example, store in 3.14, which is a double. That doesn't work. Effectively, an array is a collection of variables. So when we're talking about an individual element, we're asking, can we store a double into a single integer? No, we've never been able to do that. But notice here we're talking about, I said incompatible data types, not identical, right? Not the same. Okay, so what if this situation was switched? What if numbers was a double array? Could you store an integer into a double array? We'll play with that. And the answer is yes, but we'll play with that right now, apparently. All right, let's create an array and store some values in it. I'm going to bring up IntelliJ, and I'm going to make a new project for this by going to File, New Project. Okay, we'll go next. We'll go next. I'm going to switch folders. And I'm going to make sure I have the subfolder because we're going to call this thing Intro to Arrays. I'll expand my project folder. I'll try to expand it. There we go. Right click on the SRC, make a new Java class called Intro to Arrays. All right, we'll plug in a main method and we'll get to work there. Oh, too fast for the IntelliJ. Okay, I'm going to make a double array, I think, in this example, because there's that thing I just talked about a moment ago. And I'll call it something other than numbers, which is a joke that's been beaten to death. And we'll say something like, this is a new double with a length of 7. Okay, so we are creating the variable on the left-hand side. The variable's name is values. The data type of this variable is double array, right? That's what these brackets mean. The right-hand side is the actual object itself, right? We saw something similar whenever we're working with scanner, random. We see new, and then double array. 7 is our length here. So notice IntelliJ is happy. It's hunkadory. If I get rid of that 7, we get a syntax error. And the reason being, we have to set a length at construction. Now, negative lengths, that doesn't work. Well, it shouldn't work. What happens when I run this? Oh, man. Doing untested things. This shouldn't work. I think this is going to be a runtime error because syntactically here is an integer. Right? Negative array size exception. Interesting. So notice I'm talking about integer. What if I have 7.0? Okay, so the length of this has to be a non-negative integer. Even though this is a whole number with that 0.0, it is a double, right? If we scroll over this, we see that anything with a fractional part, this decimal portion, is going to be treated as a double in Java. So I'm going to create values, and let's put maybe a comment here. Length must be set at construction and a non-negative integer. Okay, if I want to access an individual element, right? Well, let's why don't we first see how long this thing is? Right, so I'm going to take values. That is the array. Right, this is the actual object. It gets created, but in order for me to reference it, I'm going to go through the variable. We'll do values dot length. Right, what do you expect here? Well, I just set it on line 5. It should have a length of 7, so this is just 7. Right? Note that there are no parentheses here. This is not a method call. If you try to do that, that is a syntax error. This doesn't exist. Okay, so our array has a length of 7. Maybe we put a length is a public final instance variable. You don't really need to know what those things mean, but we're actually accessing a value stored in the object. It is not a method call. Most importantly, not a method. Right? What if I try to access just one of these things, right? What if I said values at index 2? First of all, what do you think it should be? Keep in mind that values is a double array. And so we see 0.0, the default value of double. So when I make this thing, we create our list. It has a length of 7, and it's filled with a default value of double, which is 0.0. So down here, we're showing off our syntax on how we access an individual element. I'm going into values, which is the array or the list, at a particular index. This index is 2. What I'm going to get back is the element, right? The actual value that is at index 2. So this value is 0.0. The default, yeah, that's right, default value for double. All right, so obviously a list full of zeros is not going to be super useful long term. So let's change one. Let's change one of these values. Particularly, I'll do index 2, right? We just saw what 2 was. I'm going to change it to 23 here on this line. What I'd like you to notice is that I have 23, the integer that I'm saving into my array here. So can we do that? I don't see any syntax errors currently. I'm going to print off values at 2 once again to actually see, is that change going through? And yes, we see that. So you can think of an array as a collection of variables. There are 7 variables that are grouped together inside of values. I'm changing one of the variables. It was a 0.0, the default value for double. It is now a 23. So note here that we can actually store in, right? Can store in int, even though values is a double array. Values at 2 is basically a single double, right? Values, that's an array. That is a collection of doubles. Values at 2 is just one of those. I'm changing that to 23 because we're asking, can we store an int into a double? Yeah, we can do that. But you can also, right, like what if we do values at, I don't know, values.length minus 1. Let's change that to like 3.14. Well, we can do that because this array can hold doubles. If it were an integer array, we would have a problem because these would be incompatible data types. To actually see this value, I can print off values at values.length minus 1. So here we're showing syntax similar to what we did with a string, where we can reference the end of the array dynamically via its length. Keep in mind that our indices start at 0. Okay, so the very first index here is 0. Here I'm accessing the one at the very end by going through the length. Well, this has a length of 7. So minus 1 is going to give me a 6. I'm accessing values at 6. to kind of prove that, I can change this to a hard-coded 6 instead of doing it via our length. And you see we still have our 3.14 value, which we just set on the previous line. Okay, so this syntax is how we can edit our array. It is also how we can access individual elements in our array. But what if I want to see the whole thing? I think intuitively, students tend to go, well, if this is a single element, this is the whole array. So if I want to see all of it, instead of printing values at a particular index, why not just print values? That's the array. That's my list, right? You get this gibberish. It's not very useful, is it? Okay. What this is something we call hash code. It is effectively the location in RAM, the memory location. That's not very useful to us, right? If I want to see the whole thing, as it turns out, we got to use a tactic in order to do that. So printing numbers, or in our case values, can be a bit difficult as we simply can't throw the array into an SOP, a system.out.print line. The above code will print the hexadecimal location of the integer object in memory, right? Notice we got like some letters in there. That's why we're saying like hexadecimal location. Oh man, right? We see an F, we see a C. We talked about hexadecimal. That's what's going on here. It is the memory location expressed in hexadecimal. Okay, so that's annoying, right? Well, in order to do this, what we're going to need to do is loop through the array, much like we did with the string. Keep in mind that the indices, right, each individual index is an integer. This is an integer. This is an integer. It's a calculation, but we get an integer out of it, right? This is an integer. So these indexes are integers. We've seen something similar with strings. Instead, we can loop through the array and print each element individually. So here is our syntax for this. This is good. The first index is a 0, so I'm creating I, initializing it to 0. That is cohesive with what we saw with strings. And we'll keep looping as long as we are less than the length. This is very standard. The only really new concept is it's an array, and we're not using a length method. We're using the length instance variable here. But with each iteration, I'm going to access the element. If this was a string, we're looking at char at or substring. But here with our array, we're referencing it using this square bracket notation. So let's try that. I'm back in IntelliJ, and we see that this isn't working. But what we can do is plug in a for loop. So I'm going to use IntelliJ's little shortcut syntax here. I'll say for I and hit enter. Perfect. Right now it's asking, do I want to rename my counter variable? I is great. We'll say as long as I tabbed over in order to hit this condition. Okay, let's back that up. I'm going to plug in for I, which is our IntelliJ shortcut syntax to insert a for loop header syntax, right? This is, well, I talked about standard loops when we're looking at strings. This is super standard, even when it comes to arrays. Right now, the I is highlighted because I have the option of changing the counter variable. Right? I can change it to whatever I want. Notice that when I switch it to K, it changed all the other occurrences of that. So I can change this to what I want, and IntelliJ is helping me out. But we really like I. Once you are happy with your counter variable, you can hit tab. And right now, this is blinking right here because it is ready for a condition. We're going to start at index 0, and we'll say as long as I is less than values.length. Right? The name of my array in this context is values. Notice there are no parentheses here. With each iteration, I want to print values, not values, but values at the current index, which is I. Values is the array. I is an index. values at I is the element. It is the actual value that is in the array. So I'm doing this currently with a print line, as you can imagine, other ways of doing it. Oh, and here we go, 3.14. That was the end of this stuff up here. If we want, we can comment out our previous SOPs to kind of clean this up. So the only thing that's printing now is my loop, which should just be every value that is in every double that is in my values array. And you see there are 7 of them. Index 0 is still 0.0. Index 1 is still 0.0. Index 2 we changed to 23 up here. Note that it is an integer here. And once I actually store it into the double array, it is a double from that point on, right? The value is a 23, but the container is a double. So once it goes into there, it's going to store it as a double for the rest of the program. So we saw the same thing when we're working with double variables. So we see a 23.3 and then all the way to our 3.14, the last element, which we changed up here on line 13. So there's the whole thing. Now, it is a bit annoying that we have to use this for loop, but you can imagine this is going to be a super important tactic for manipulating the values or checking to see what is in the array. This concept is awesome. Keep in mind the whole point of this is that we want to take related values and group them together. What are your averages on all of your tests to get an overall test average? What were the temperatures in your science experiment? What were your readings over time? That sort of thing. That's the point, is that you take values that are related, you're able to group them together in one object and keep them together. Otherwise, you're looking at just a bunch of random variables, but you got to name each one. Oh, yuck. Okay. So the process of accessing each element, the way that we just did, is known as array traversal or traversing the array. I may have used this terminology when talking about a string, traverse the string. The root word here is like travel, basically. Right? We need to travel through the array. Array traversal is common practice that is required for various functions, such as filling an array. Maybe you need to start your array, right? It starts at 0, but maybe that's not a good default value for you. You want to put something else in it. Averaging values. Counting matches. How many times does something occur in your array? Finding the min or max value in the array. Oh, awesome. Let's recap. The values that are stored in an array are called elements. The maximum number of elements that an array can store is known as the array's length. True or false? The length of an array must be specified upon construction. True. You have to put something there, right? If I just leave this off, that's a yikes. When a Boolean array is constructed, it is filled with blank values. False values. I would also accept default values here, but false is the default value for Boolean, right? I like to think of this as the 0 of Boolean. This is 0, 1 is true. And that math doesn't technically work out, but that's the way I like to think about it. Each element in an array can be referenced using a number known as an index. The first index in an array is 0. Attempting to access an index that does not exist will generate an index out of bounds error. I would also accept array index out of bounds. I would also accept maybe runtime error, right? Because this happens at runtime and will actually trigger an exception in doing so. Why don't we try an index out of bounds exception? Let's say that right here before I try to print my array, I'm going to change values at -1 to be just 2.9. Interesting enough, this is yellow. This is not red. This is not a syntax error. I can hit this run button. When I do, we got a problem. This is what I was talking about where it says array index out of bounds exception. So if you have a string and an array in the same program, this could be helpful. It even tells me where I went out of bounds. I went -1 for a length of 7. I don't feel like it used to tell me how long it was. Interesting. So that's out of bounds. What if I try to change the element at index 7? we see we get our array index out of bounds exception again, and it is a 7. Now, what I am saying here, though, is that this is at runtime, which means it's going to actually execute statements. For one thing, I can run. If this was a syntax error, I couldn't even click this button, right? But it is running, it's running, it's running, it's running. And then whenever we go to change this to a 2.9, that's when it breaks. It's shown as an exception. All exceptions are runtime errors, right? Index out of bounds exception. Okay, so this is a runtime error. I would accept that here. Given a double array called values, how do we get the length? I know it's a 10. I see that here. I'm asking, how do we get it? Well, that would be using values.length. Notice there's no parentheses. The process of accessing each element in an array individually is known as array traversal, or traversing the array. That is the end of our slides, and that's going to be the end of our video. I'll see you in the next one.